Thank you very much. Dear friends, good morning to all of you. So, dear friend, my talk is on nano manufacturing towards nano finishing. So, this is one of the latest topic, one of the latest demand in industry. Now, everybody is talking about nano. So, being a mechanical engineer, we are all are from the fraternity of mechanical engineering. So, we should also talk about nano manufacturing, nano. So my theme is on regarding the nano manufacturing. What are the areas under which nano manufacturing found the applications, in particular mechanical engineering? So we are the fourth and forward power which will decide our future. Being the mechanical engineer who are working in manufacturing area. So dear friends, I will not teach you the particular scheme, particular process by which we can achieve the nano finishing or nano manufacturing, but I would like to tell you about how we can generate nano finish by producing the nano manufacturing. Do you know what is engineering? I would like to share with one thing, what is engineering? Whether it is computer science engineering, whether it is mechanical engineering, whether it is electronics engineering, we should know. I try my best to explain this term by taking in one example, how the pressure cooker was developed. How the pressure cooker was developed. So dear friends, pressure cooker was developed in kitchens because need was felt in the kitchen. In the early days, the lady used to do work at home. They remained at home most of the time, but at the time changes, they start moving from one place to another place. They start moving outside the home for their job work, for their business work, whatever it is busy. So they become busy, but the everybody have time of 24 hours. So ladies has their role become double. They have to manage their home as well as they have to do the job outside their home. Now time is very short. Then the need was felt. They felt a need. Okay, why not? I can save my time, which I spent for the cooking of the food. So this need was felt in the kitchen. They felt that I need that utensil which can cook the food as soon as possible, also preserve the nutrients. So this need come out from the kitchen, from one house, two house, every house. This need was come out from the kitchens into the market, and into the market the clever people are sitting. So my dear friends, who are the clever people? The clever people are the businessmen. The clever people are sitting in the market. They capture this idea and start developing one utensil, one equipment, one product, which is called pressure cooker. Now we are living in a dynamic world. The pressure cooker which was developed around 20, 30 years ago is not same as today. Its size has been changed, its appearance has been changed, its color has been changed, its material has been changed, everything has been changed. So we are living in a dynamic system. So first they create one idea in their mind, the utensil should be like this. They develop one prototype, they check it and send to the kitchen for their feedback, and they collected the feedback. Ladies, whether from the kitchen, whether this product serve your purpose or not, what modification you want more in this product, in the pressure cooker. So by this way, we have developed the pressure cooker. So this today's pressure cooker is different from the earlier one. So first step in engineering, whether it is mechanical engineering or any other discipline of engineering, we have to design the product. Then we have to prototype the product. Then we have to test the prototype. After testing the prototype, we have to go for manufacturing, development of the product, and then go for delivery. By this way, we make a product of different nature. Now coming to another word, nanotechnology. Dear friends, everybody is talking about nano. And we are engineer, we know what is the meaning of the nano. Nano means very, very small. How much small? if we are talking in the terms of meters, it is 10 power minus 9 meter, that is 1 nano. Now, do you think, have you noted down what as the time changes, the size of the product goes on decreasing? So this was the size of the computer which I have seen particularly myself at IIT Kanpur around 25 years ago. This was the size of the computer. You can see on your screen at the top, you can see on the screen of your top, this is the size of the computer. But now you see, this is the size of the computer. The computer is available on the wristwatch in the form of wristwatch. The size has been changed. The working has been increased. The processing has been enhanced, but the size has been reduced, decreased too much. This is the change in the size from the last 20 or 25 years. Dear friend, this is another comparison of the size. You know, many of you have seen the floppy disk. Its capacity was just 1.4 MB. And now you can imagine what is the size of this floppy disk. Its capacity just 1.4 MB. Now we have the data card of 60 GB in terabytes, TV, 60 terabytes, 120 terabytes, and the size is too much, very, very small. So my question being the mechanical engineer, dear friend, who have manufactured these terabyte memory cards? Electronic engineer have manufactured or computer engineer have manufactured? No one have manufactured these. Only the mechanical engineers have manufactured this. Mechanical engineers have produced these kind of products. So can we produce these kind of products with our conventional cutting methods in our workshop or in our laboratories? The size is too small, very, very small. Another. So dear friend, this is another example of the size. On your right side on the screen, it is drone. Around 1 year or 1.5 years back, there was an announcement from the Amazon.com in US that they will deliver the product by drone within half an hour from the time of their enrollment, from the time of their purchase. Within half an hour, they will deliver the product. It's not possible in India, but it is possible in US, in the developed nation or other European countries. How it is possible? Who have manufactured this drone? Electronic engineer, computer engineer have not manufactured these drones. Mechanical engineer, you people, myself and other many mechanical engineers have manufactured, prepared, assembled this drone. Now the question arises, the size of the drone is very, very small. And moreover, drone is not a single product. It is an assembly of number of components. The size of the drone is small. Now you can imagine the size of the each component. How these small component has been manufactured and where these small size components has been manufactured. On what machinery these small components has been manufactured. This is the question for being a mechanical engineer. And this is the latest trends in mechanical engineering. Now this is another photograph which represent the glimpse about the size of the component regarding nanotechnology. Dear friend, on the right side picture, this is robot, very small robot. This is called nano-robot. So 1 year back, last year, I was in UK in Cardiff University to do my experimentation on a research visit. I spent around 2 months in one of the lab in Cardiff University, UK. So do you think what they are doing over there? Now imagine, okay, if I have a pain in my head, I have to take one tablet, for example, paracetamol or kerosene. I have to take one tablet kerosene. So tablet will go in the whole of the body. It mix with the blood of whole of the body. But my pain is only in the head. Why this effect will go whole in the body? Why not only in the head? Do you know the excess medication will lead to the damage of the many organs. It will affect the liver, it will affect the kidney. Why not I should take that drug which goes to that point where is the problem and rectify the problem. So nanorobots are the latest technology in which drugs are injected in the form of the nanorobots. The nanorobots are injected into the arteries or veins of the patient. These are nanorobots will go into the veins, will mix into the blood and will reach at that point where is the problem. They will rectify the problem at that point and will return back. Dear friend, it looks very funny. Very funny. These days it looks very funny, but it's not actually not funny. Do you think around 5 years back when there was no mall culture, around 5 years back, around 10 years back, we used to purchase the item from the shop. But after 5 years, there was a mall culture. Everybody is going to mall. In Chandigarh, there are so many malls. Everybody is going to this mall, that mall. Now these days, the mall culture is also going off. It is gone out. What is the new culture? New culture is online purchase. So we are purchasing online. Most of items we are purchasing online. So the culture is changing because we are living in the dynamic world. We are changing continuously. Similarly, today this looks very funny. This looks very, entertaining. Okay, the nanorobot will go in our body, will mix into the blood of our body and will reach at that point where is the problem. They will rectify the problem and return back. It looks very funny, but real, my dear friends, many of my friends are working in this area in my university, in Punjab University, and in abroad. They are manufacturing, they are working on these ideas, nanorobots, and within 2 or 3 years, it would be become very reality. So this I have seen in Cardiff University in UK. This is another glimpse of the nanotechnology in Cardiff University. When I was doing my experiments in my lab, in adjoining lab, few researchers were working on this project. So I have asked my supervisor over there. I asked my professor over there, sir, what they are doing. He told me on the left side it is LED held in the hand of the researcher. So I asked them, sir, what are they are doing? What they are doing from the LED? He told me, okay, these LEDs are to be fit into the right hand side photograph. These are the seats where LEDs are to be fit. Then I asked him, okay, no problem. I understood this. But next, where they will fit it? So my dear friends, can you imagine where they will fit it? They will fit it into the human body. For what purpose? They want to know what happens to the food which we take bite by bite. We are taking food bite by bite. It will come in into the esophagus, then come into the stomach. In the stomach, many enzymes will mix with the food, then come into the liver and intestine and so on. They want to know it, how enzymes are mixed with the food, how enzymes or hormones are released, what happened to the food. They want to know it online. They want to see it on the monitor. They want to monitor it. So this kind of research they are doing it. Now you can see these are the very small tiny particle, their size in microns. Their size in micron. In photograph it looks bigger, but their size is very small. First question is that whether this material is compatible with the human body or not. Number two, is this material make some reaction with the tissue of the human body or not? Third question, whether it compatible with the human body tissue or not. So these questions are there which the researchers need to answer it. Now, can you imagine computer engineers or electronics engineer or electrical engineer have manufactured these small components? No, my dear friends. Mechanical engineers have manufactured these components, very small components. This is the need of the hour today. So the research is going for the benefit of the human body, humankind. I always emphasize on this idea, our research should benefit the humankind. But now you think how this mobile has been developed, where this mobile has been developed. Dear friend, this mobile is developed for the benefit of the mankind, for our benefit. No doubt there are other disadvantages or also these days have been developed. But the main purpose was to know the location of the human being, to contact the person immediately. This was the idea behind it. So the research is going on. We should, as a mechanical engineer, to do that research which will help the mankind who have developed the stent which we are used in heart while there is a heart attack to the patient. Mechanical engineer have developed these stents. Implants, in accident when some fracture occurred, we are using some nut, bolt and plates we inserted into the human body. Who have manufactured these implants? These implants are manufactured by the mechanical engineers, you people, me. So we have to think in that direction, how we can help the human mankind, how we can help our race, so that we can make their life, our life, easy, and the life of the coming generation very good. So dear friend, this is another glimpse of the nanotechnology. On the left side, it is mirror, and mirror is used to see ourselves. We, in the morning, we see ourselves in the mirror, how I look. Similarly, how the surface finish of the mirror is very smooth. Why not we make that kind of surface finish from the metal surface? On the right side, it is metal. Why not its surface finish? It looks shine as of mirror. How we can make it look shine? How we make it look transparent as of the metal? And what is its utility? What is the need has been developed to make it such shine, such very good surface finish? I want to share this idea. This also happen these days. So these are the other glimpse of the nanotechnology. On the upper side, it is mesh factory. It is not in macro size, it is in micro size, nano size. So dear friend, my talk is on nano manufacturing towards nano finishing. First of all, nano. So as I have told you, everybody is knowing what is nano. Nano means 10 power minus 9 meter. But I want to share its physical concept with you. Nano does not mean only 10 power 9 meter, minus 9 meter. It is the size which is 50,000 times smaller than the human hair. So you can see this is human hair of the head, 50,000 times smaller than this human hair. So can you see this small size? Now imagine 1 millimeter in your mind. What is 1 millimeter on the scale? This is 1 millimeter, very small. In mind, please imagine it. 1 millimeter. 1,000 times smaller of the 1,000 times smaller of 1 millimeter is called 1 micrometer. 1,000 times smaller than of the 1 millimeter is called 1 micrometer. We cannot see that 1 micrometer. Now imagine 1,000 smaller of 1 micrometer. That is called 1 nanometer. If we are not able to see 1 micrometer, how we can able to see 1 nanometer? It is very small, and we are talking about the nano manufacturing. Can we manufacture that product which is not visible on our center lathe machine, which is available in workshop of the most institutions? It's not possible. It's not possible. Even we cannot work in millimeters on lathe machine. and we are talking about the manufacturing of the product in nanoscale on our center lathe machine or drilling machine or milling machine available in our workshop. So this is the challenge. These do. Our demand is raising day by day. Our demand is for the small size, very, very small size, day by day. But we don't have the facility, but we don't have the technology on that we can manufacture the component at nanoscale or micron scale. So this is one of the challenge. So this is the shock our students are facing, which they are moving from the institution to the industry for their job. In industry, the latest technology is available, but that technology is not available in institution, and that is the lacking, or you can say limitations of our education system. So that is another aspect. We are not going into that aspect, but we are focusing on ourselves. What is the latest demand of the industry and what our students are learning in the institutions. So definitely there is a big gap between these two, and we have to bridge this gap. We have to fill this gap so that our product will become sellable. Our student can easily get their job into the industry. So dear friend, coming to again this topic, another word is manufacturing. Another word is manufacturing. Everybody know what is manufacturing. So usually people understand the machining of the metal is called manufacturing. The removal of the metal from the workpiece to make it usable, to make it according to the application, it is called manufacturing. No. Beside this, there are many processes in which we does not remove the metal, but even then we are able to make a product. Many processes are there, and everybody know. For example, welding. In welding, we does not machine the metal. We does not remove the metal from the surface of the workpiece. Even then, we are able to manufacture a component product. For example, casting. For example, powder metallurgy. So many processes are there which comprises manufacturing, and machining is one component of the bigger term. The bigger term is manufacturing, and machining is one small term under the umbrella of manufacturing. Now coming to machining, what is machining? And we know what is machining. Machining is nothing. It is the process of removal of the metal from the surface of the workpiece with the help of a cutting tool. The cutting tool may be single point cutting tool, and the cutting tool may be of multi-point cutting tool. The multi-point cutting tool is called cutter. Otherwise, it is called a single point cutting tool. So it is the process by which we remove the metal from the surface of the workpiece with the help of single point cutting tool or multi-point cutting tool to bring it into a specified shape and size. I have demonstrated it with the help of a lathe machine, lathe machining process, lathe operation, turning operation. So these are the conventional methods of the machining. Whether this is on the left side, it is turning operation, right side it is drilling operation, and the bottom side it is milling operation. All operations are there. You will witness a very common thing among all these operations. I will show it later on. So this is the grinding operation. In grinding operation, there is one cutting tool and there is one job, and there is boring and broaching operation. You will see in all operation, whether it is grinding operation, whether it is boring operation, broaching operation, drilling operation, milling operation, whatever it is, there is one physical cutting tool and one physical job, number one, and both have the physical contact with each other. Physical contact. This is job, this is cutting tool, both have physical contact with each other. Now, do you think the cutting will takes place if there is physical contact between the job and the workpiece? My dear friend, it's not possible. It's not possible unless until there is a relative motion between these two. Now you see on lathe machine, there is a relative motion between they have a contact and they have a relative motion. On drilling, they have contact and they have the relative motion. On milling machine, milling operation, they have the contact and they have the relative motion. Every operation, There is one physical cutting tool and other is jaw. Both have physical contact with each other. And the third condition is that there is a relative motion between these two. So dear friend, there is a physical cutting tool. The tool has a direct contact with the workpiece and there is a relative motion between them. And this is the biggest problem for us. This is the biggest problem for us these days. What is the biggest problem? The biggest problem is this. Due to this direct contact between the tool and the workpiece, the chips are formed. There is a fight between the tool and the workpiece. Who will win? Which is stronger? And intentionally we make the tool stronger to remove the surface, to remove the metal from the surface of the workpiece. Otherwise, it would not happen. Otherwise, otherwise the tool will become blunter. Intentionally. So there is a fight. Now you know when there is a fight between the two person, there are vibrations. Halchal, there are vibrations. So these vibrations are chatters are generated over the fight between these two workpiece and the tool. Due to these vibrations and chatter, this is undesirable, which we cannot remove. For to manufacture the component and nanoscale, to manufacture the component at microscale, we does not want these vibrations. And my dear friends, in conventional machining, without vibration, it's not possible to remove the metal from the surface of the workpiece. So due to these vibration and chatter, the surface finish becomes rough and matte. The surface finish becomes rough and matte. If we see that surface with naked eye, it looks very fine. These are the components manufactured by the conventional machining method, whether it is drilling, milling, turning, facing, shaping, planing, whatever, grinding, whatever it is, it looks very fine, very fine. But when we see the same component under microscope, there are series of ups and downs are there. It does not look flat surface. It's up and down, crest and valley, troughs and valleys are there, which we does not want this. Our surface should be like this, but actually it is like this. And we have to remove this ups and downs, crests and valleys. Now the question arises, where are the application of these flat surface, super finished surface? What are the applications of these surfaces? Dear friend, these are the applications of these surfaces. So this is the Audi engine block. Now Audi car. This is the engine block of Audi car. Now, do you know the basic characteristic of these cars is that it catches a speed of 300 km/h in just 5 seconds. The pickup is so much high. So dear friend, the question is arises, how it is possible? How this kind of power is generated? 300 km/h speed catches in just 4 or 5 seconds. How it is possible? If my surface is not smooth, my lot of power will be wasted out to remove that asperities, ups and downs. My lot of power will be wasted out. My surface, the surface of the engine, where piston is reciprocating inside the cylinder walls, should be very, very fine. Very fine means super finish. Super finish means micro finish. Micro finish means either nano finish. It should be at that level. That's why we need this kind of surface finish. That's why we need that kind of nano finish. This is one example. I will show another example. So this is the V6 engine block of the same automobile, same car, Audi car. Now you see, engine is not a single product. Engine is not a single component. It is an assembly of number of components. Many components are assembled together. You can see thousands of nuts and bolts are fitted over there. Thousands of parts, hundreds of parts are fitted over there. Some parts are reciprocating each other. Some parts are moving against each other. Some parts are rolling against each other. If the surfaces are not smooth, there will be vibrations. And another characteristic of these vehicle is that these car is that inside the vehicle, inside the vehicle, there is no noise. There is no noise. This means there is very less noise in the engine. So how I will get very smooth running of the vehicle if the surface finish of the mating component is not smooth? The components or the surface of the mating component should be very smooth so that there should not be any vibration. So this is another requirement of the nano surface finish or micro surface finish. So this is the BMW cylinder head. Now you can easily imagine how many components are assembled together, how many small nut and bolts are assembled together. If their surface is not smooth, you can easily imagine how much vibration would be there. Can you imagine in such a situation it will catch a speed of 300 km/h in just 5 or 4 seconds? If the components are not smooth, if the components are not fine, if their surfaces are not fine, if the surface finish is not fine, it's not possible, my dear. So this is the challenge for these today mechanical engineers to manufacture that components which have a very fine surface finish, micro surface finish or nano surface finish. So dear friend, this is another example for brake assembly. Behind, usually in India it becomes compulsory from 2017 onward, 1st January 2017 onwards, every car must have ABS. ABS means anti-lock braking system. You all know behind the car one word is written over there, ABS. This is anti-lock braking system. So what is the function of this anti-lock braking system? Means in emergency, brake should apply on the tires to avoid the skidding, So in accidents, in emergencies, microsecond is available to do the action. Microsecond is available. Nanosecond is available. Emergency will not give time. Emergency will not give you time. So in emergency, if my components are not properly assembled, if the components of the ABS system are not properly assembled, do you think it will apply in emergency? So the purpose of ABS will be defeated out. So that's why, my dear friend, it is necessary that surface finish, surface modification of the component, the mating of one component with other component should be very fine, should be very proper. So there are many examples. So the human nature is of very different kind. The person wants big house, big car, but small components. Other components should be very small. Now you can see we are living in this world, but we are not sensing the changes which are going on continuously in daily life. Everybody uses the water cooler. In summer, we use the water cooler to cool the house. In the water cooler behind, there is small pump, and the pump is used to circulate the water in the water cooler. In early days, around 5 years back, this was the size of the motor and pump. Now, this is the size of the motor and pump. This is the size. And this motor and pump is more efficient than of this size. So the changes are going on. The changes are going on daily, but we are not imagining. So my dear students, it is very important for you to sense the changes which are going on daily around you, in every area, in your institution, in your home, in your vehicle, in your car, in your motorcycle. The changes, the system is going smaller. The system is going more efficient and go. Now the question arises, what technology, what engineering we are learning at our institutions is fulfilling that requirement or not? If not, then we have to think in that direction. And this is the duty of our teachers. This is the duty of the management and not of students. So in these all applications, many parts are rubbing against each other, many parts are rolling against each other, many parts are sliding against each other. So if the surface will not be smooth, lot of power will be wasted out. So my dear friend, we have to save this power. We have to save this power. How we can save? We can save this power if my surface is very, very smooth. Now the question arises, how I will manufacture that smooth surface, how I will manufacture that micro surface, how I will manufacture that nano surface. This is the question. So dear friend, this is another challenge. The size is decreasing day by day. On the left side, this is the micro lathe machine. Lathe machine, the center lathe which is available in a workshop covers so much area. This is the lathe machine available on the palm of the hand. This lathe machine have the head stock. This lathe machine have the tail stock. Tool post means each and every part as of the bigger lathe machine, but in this very small size, very, very small size. Now you can imagine this is the size of the lathe machine. You can easily imagine what is the size of the headstock, what is the size of the tail stock, what is the size of the lead screw on it, what is the size of the motor here. How we will manufacture these small components on lathe machine. It looks very funny these days. On the right side, it is micro factory. Micro factory. Future will be of this. Customer demand is changing day by day. I want this type. Another customer came, he want this different type of the product. Another customer came, he want this type of the customer. The company will change the production line for one component or 5 component or 10 component. No. Why not our production line should we have that capability which have the flexibility, which can manufacture any component of any dimension and any size and any specifications. This is the need of the art. So micro robots, lower bottom, I have given you the glimpse where we can use the micro robots or nano robots, applications of the robots. So dear friend, other applications of the micro and nano components, the multi-gear speed reduction unit is here, micro medical instruments, and then micro medical implants. I want to share this technology with you. In by chance, in some accident, some person got the accident, his or her teeth are broken out, not completely broken out, but half teeth are broken out. So few years back, around 1 or 2 years back, this was the technology. If your one tooth is halfly broken out, you have to remove the full tooth and have to implant with new one. My dear friend, this is not good option. Why not we why not we fix the artificial tooth only in small part as same as the small part has been removed. जितना उतरा है उतना ही टूथ नया क्यों नहीं लग सकता, चिपक क्यों नहीं सकता साथ में. So this is the main requirement, and this requirement is going to be fulfilled very soon. Now the small part of your tooth will be pasted with the remained part of tooth in your mouth, and it will work fine. So the tooth is not for showpiece. The teeth are not showpiece. We have to use these teeth for chewing our food, for hard food or soft food, whatever. So the fixation, the binding material which is used to bind the extra tooth with the older one. Now you can imagine what is the strength of that binding material, binder. So this is the requirement from the material science point of view. So our students, you people are studying material science, somewhere it is material science and metallurgy, somewhere it is material science, somewhere it is materials and manufacturing, somewhere it is another subject. So my dear friend, there is also need of advancement, and advancement is going on in material science subject also. This is the requirement, and this latest is going on. So these are the challenges. So the main purpose of my talk, my lecture is just to just to give the glimpse what the latest technologies are going on, what are the latest requirements are going on, so that we can prepare ourselves to come at that level. So many examples are there for the from the nanotechnology point of view. For mechanical engineer, this is micro engine, this is micro motor, and these are the micro nut and rivets. For comparison, the matchbox stick is placed near to it. Now you can easily see what is the size of the bolt, what is the size of the nut over there. These are the nano weapons. Nano weapon. Now these days, the wars are fight by the soldiers. My dear friends, within couple of years, 4 or 5 years, the war will not be fight by the soldier. It will be fight by the products. It will be fight by the artificial soldier, not a living soldier, but by the machines. Now you see the lower left corner, right hand corner. This is mosquito. This is mosquito. So dear friend, this is not mosquito. This is soldier. This is soldier. Now you can imagine the size of this soldier, small mosquito, and this small mosquito is not single product. It is an assembly of number of components. Now you can imagine where these small component will manufacture, on what machinery these small component will manufacture, what kind of finishing you will require to assemble these small manufacture. So there was Hindi picture. Hindi picture was its name was Makhi, and it is a Tamil version of picture Makhi. In that picture, the lady have made the goggles for the Makhi, have made the dress for the Makhi, and so many clothing for the Makhi. So how these small goggles have been manufactured? Where these will manufacture? On what technology these manufacture? This is the challenge for the mechanical engineers. So this is the question. Can you imagine we can manufacture all these components at nano size by conventional methods? Conventional method means lathe machine, turning, drilling, boring, milling, grinding, etc. So dear friend, the answer is big no. It's not possible to manufacture these components by our conventional methods. This is the one challenge. The size is reducing day by day, and we are not able to manufacture these very small components at micro scale or nano scale by our conventional methods. There is another challenge also. This is the second challenge. Due to the industrial requirements, the job material going harder day and day, harder day by day. This is the age of the mnemonic alloy. This is the age of the HSTR alloy, high strength temperature resistant alloy. So this is the age of the composite alloy. This is the age of the super alloys. Composite. I would like to talk on composite. I want to share one thing with you. Why Kalpana Chawla visited space around 10 years back? She lost her life with other crew members. Why NASA is sending the astronaut to the space? Not for fun. The answer is not for fun. And by returning, they lost their life. Do you imagine? Have you the idea why Kalpana Chawla visited space? Kalpana Chawla visited space for the benefit of the human mankind. We would like to know what is the effect of vacuum, what is the effect of other environmental conditions, what is the effect of the space conditions on cancer cells. Her mission was like this. So dear friend, every research have their motive. Motive is benefit to the mankind. So coming to mechanical engineering, while they returning from the space, their spacecraft was heated up, their thermal tiles were broken out, and due to the friction, lot of heat energy generated, and they lost their life. Now the question arises, this means the thermal tile could not bear that temperature. Why not we develop that material which can bear enormous temperature, which can bear high strength temperature resistant alloy. So dear friend, this is the requirement. This is the today's requirement. We need that kind of material which have very much high strength as well as can withstand high temperatures. We need that kind of material. Can we machine that material on our conventional lathe machine, drilling machine, milling machine to manufacture the components? This is the problem. It's not possible, my dear friends. It's not possible. Another is composite material. It is not composite, its property, it is not metal, it's non-metal, it's different material, which is called composite material. I'll give you the example. So dear friend, this is nano car. Nano car. Early days, we have Maruti 800 car. The Maruti 800, mostly it is made from the metal, especially its interior parts made from the metal. Now you see the Alto 800, 800 new or Alto 1000. There is very less amount of metal has been used. Metal is used only for the chassis and engine. Interior is mostly made from the different material, and that different material is called composite material. I would like to share this wind screen. This wind screen, early days it is made from glass, but now these days it is not made from glass. While you are traveling from one place, if you see some accident, there was accident, and during the accident, the first step of fracture came to the wind screen. Wind screen टूट जाती है. Early days, the glass was spread out pieces from here to there. Now these days, the wind screen is not spread here and there. It bends out. It bends out. How this is possible? So this means this wind screen is not made from the glass. This is made from some different material. And dear friend, that different material is composite material. In glass is a brittle material. And in glass we make brittle material. जैसे जरा सा, if we give small shock, it breaks. To make it more ductile, we add some fiber into the glass and made the wind screen. And that wind screen, that material is called fiberglass. And fiberglass is nothing, it is composite material. It is composite material. So these are the latest technology. Can you machine, can you finish wind screen made from composite, made from fiberglass by using the conventional methods? So dear friends, it's not possible. It's not possible. So this is the Boeing 777. Most part, 30%, more than 30% part is made from the composite material. But we are teaching in our institution, in our workshop, in our labs, to machine the iron, to machine the metal. But usually now these days, very small amount of metal is used to manufacture the component, to manufacture the products. So we have to revamp our education system. We have to see this is the latest technology which is going on, and what we are teaching to our student, what the industry is expecting from us. That's why the placement is very, very less. And this is one of the reason the placement is less. So there is another requirement. These are the two challenges. Size is reducing day by day. Material is changing day by day. We are not able to cut our conventional methods, these kind of new materials. There is a third challenge. The third challenge is that the requirement of intricate and complex shape in jobs. Turbine blade is going on in complex shape. Aircraft rocket engine parts are going in complex shape, very complex geometry. How are this is possible with these machining methods? It's not possible, my dear friend, these days. It's not possible. Then what is the alternative? So dear friends, the alternative is to meet these requirements, to solve these problems. The answer is please use non-conventional methods. Non-conventional method, non-traditional methods, advanced manufacturing methods, AMP. non-traditional methods. So these is the requirement of these days. In conventional method, whether it is lathe machine, drilling, milling, boring, grinding, whatever, there was cutting tool. Now here there is no cutting tool. In non-conventional method, there is no cutting tool. There was physical contact between the tool and the workpiece in conventional method, but in non-conventional method there is no contact. जब tool ही नहीं है तो contact किसके साथ? So there is no direct contact of the tool with the workpiece. And the third, there was a relative motion between the tool and the workpiece. Here in non-conventional method, there are no contact and no question of relative motion between the tool and the workpiece arises. That's why there are no conventional stresses are there. That's why there are no vibrations. That's why there are no chatter between the tool and the workpiece. That's why the surface finish on the workpiece is very, very fine. We can achieve nano surface finish on the surface of the workpiece to meet our daily requirement, which are coming day by day, daily. So there are many non-conventional methods are available. This is the list of the non-conventional method available, or you can go with any one of the non-conventional methods. So this list and the processes of non-conventional methods are available in various non-conventional books. So you can see from that. So my work is on electric discharge machining, EDM. So I am working on EDM from the past 15 years, 15 years. I did my master's in this area. I did my PhD in this area, and I have guided 10 PhD theses in this area, electric discharge machining. So I am not here to explain you the principle of the electric discharge machining. What I would like to give you the idea what new things are going on in electric discharge machining. Electric discharge machining is one of the most important manufacturing process. It is now these days, it is available in each and every industry. So due to this reason, sometime it is called conventional machining method. It's not non-conventional. It is available in each workshop. It is available in each and every industry. It is available in each and every tool room. So sometime it is called conventional method because of its easily availability. Otherwise, it is a kind of non-conventional method. It is one of the most important manufacturing process which can produce geometrically complex shape in hard and brittle material. And the biggest advantage that you can machine any material irrespective of its hardness and toughness. But the condition is that the material should be conductive in nature. The material should be conductor of heat and electricity. It can machine any material, whether it is high hardness, whether it is of high toughness, it can machine any material. This is one of the biggest advantages of this kind of machining. So dear friend, this is the principle of EDM machine. I am working on this. I am working in this area from the last 15 years. Around 5 years, this machining method was developed around 50 years back, 60 years back, around in 1960, 1950, 50 or 60s. I want to share one important thing with you. After its discovery around 60 years back or around 70 years back, still it is not clear how the machining is done. Still it's not clear. The phenomenon is not clear how the machining is done. Well, because the gap between the tool and the workpiece, the gap between the two electrode is very, very small, very, very small. The range of this gap is in microns, say 20 microns, say 50 microns, say 100 microns, 100 micron, 100 micron. Again, I am repeating 100 micron. It's very, very small. We cannot apply any sensor over there. We cannot apply any camera over there to see what is happening, how the machining is going on. We cannot see. That's why we are not sure how the machining is going on, how the machining is done, how the current able to machine the material from the surface of the workpiece. But we have accepted the mostly widely accepted theory behind it, which was given by Benedict, the physicist Benedict. So the gap between the tool and the workpiece is very, very small. When a proper voltage is applied between the two electrode, one electrode is called tool electrode and other is called a job electrode. The job is usually fixed at the bottom while the tool is fixed at the top. Both are submerged into the dielectric fluid. Dielectric fluid means some kerosene oil or some paraffin oil or some transformer oil, because the temperature generated in microseconds between the two electrode is same as in the core of the sun. Too much temperature is generated. We cannot handle that temperature. The workpiece material cannot bear that high temperature. So to make convenient to bear that temperature, we immersed the workpiece into some dielectric. So this is one of the requirement why dielectric fluid is used in the case of the electric discharge machine. So I'm not going to into the detail regarding the principle of this EDM machine. This is available in books. So who is interested to learn more in this area, you can refer your books. You can refer your teacher also. Applications of EDM. These are the various applications of EDM. Now you can see this application in this is the leaf. Leaf is available. You can see the intricate shape of this leaf, the complex shape of this leaf. Can you imagine we can manufacture this intricate and complex shape by our conventional method? It is not possible. So my dear friends, it's not possible. It is impossible to manufacture these kind of intricate and complex products, geometries on the surface of the workpiece. These are the complex mold geometry easily produced by EDM. These are the machining and finishing of the complex geometry, washing machine, agitator, and tooling by EDM. These are the other various applications of the plastic mold and die geometries. So in EDM, everything is not rosy. Picture is not rosy. So there are thorns also. EDM is also suffered by some limitations, and one of the limitation is instability or arcing. Arcing is nothing. The gap is very, very small between the tool and the workpiece. The debris, the extra material which is removed from the surface of the workpiece is clogged, is jammed in this small gap. Due to this short circuiting taking place, and this short circuiting is called arcing. This causes instability to the machining operation. So many efforts has been used to remove these problem. Somebody have the rotary motion to the electrode, somebody have given the orbiting motion to the electrode, somebody have given the planary motion to the workpiece. The purpose is to clear the gap. So many have used the ultrasonic vibration, many have suspended some powders into the dielectric fluid. So my dear friend, my research work is on this. The nano finishing is achieved by this fourth category, that is by suspending some suitable material into the powder form into the dielectric fluid of the EDM. So this EDM is called powder mixed EDM. The introduction of powder into the discharge gap has been reported for improving the machining stability and efficiency effectively. So this technique emerged as one of the advanced technique in the direction of enhancement of capabilities of the EDM process. In this process, a suitable material in the powder form is mixed into the dielectric fluid of the EDM. As a result, what happens? The insulating strength of the dielectric fluid decreases, and it allows the decrease in the breakdown voltage. The decrease in the breakdown voltage in turn increase the gap distance between both the electrode. It makes the gap wider and enlarged. Wider and enlarged. As a result, the passes of the crunch become easy. As a result, uniform machining taking place. So we have found a very good result by mixing the powder into the dielectric fluid. It has been brought a significant reduction in the machining time in comparison to normal EDM. How? A roughness value of 5 micron is obtained on SKH51 material. By EDM, we can obtain 5 micron in 5 hours, but by suspending the powder particles into dielectric fluid, we can achieve it in just 25 minutes. In just 25 minutes. So for this we have to manufacture, we have to design and develop an experimental setup in our laboratory. We have developed this experimental setup in our laboratory. So this is the detail of the experimental setup which is developed in our lab in my university. So this is the detail of the parts for experimental setup: machining tank, workpiece fixture, circulating pump and nozzle assembly, stirrer assembly. This is the workpiece detail. So we have chosen high carbon, high chrome die steel as a workpiece material. We also chosen H11, and 31 titanium alloy MMCs. We have tried each and every material to machine the workpiece by powder mixed EDM. So this is the copper tool used for experimentation. Its purity is 99.9%. This is the real photograph of the experimental setup for powder mixed EDM we have used in our lab by our students and myself. So recently we have used the carbon nanotubes. We have added the carbon nanotubes into the dielectric fluid and got very good result in terms of nano finish. For that, we have one research project from AICT. Its title is Nano Machining of Metal Matrix Composites by Electric Discharge Machining using Carbon Nanoparticle. This is over successfully. We have achieved this, and from this research work, we have published 11 international journals and journal publications and awarded the record citations across the world. So what happened in this process? By adding the carbon nanotubes into the dielectric fluid, this is the SCM photograph of the workpiece surface machined by powder mixed EDM and compare with conventional EDM. So what happened? A roughness value of 1.5 micron, which is achieved by the EDM process, has been reduced to 100 nanometer to 300 nanometer by powder mixed EDM. So this is one of the achievement of our research work. We brought down the the surface roughness in the range of 100 to 300 nanometers. So this is we have proposed the machining mechanism for powder mixed EDM. So to know what is the role of the powder into the dielectric fluid of EDM. For on this topic, our work has been published also. Eleven international papers have been published. This is the detail of the paper which we have published in this. So I would like to share another thing. What we are doing in our lab regarding use of powder mixed EDM at UIT in my institution, Punjab University, Chandigarh, and recently our university, Punjab University, declared around a couple of days back, declared one of the best university in India, best university in India, ahead than many IITs, manufacturing and modifying the implant used in orthopedic applications. So what we are doing, how we are using our technology for the benefit of the human mankind. So like other parts of the body, bone become damaged or weakened by age, accidents or diseases. It is estimated that 90% people over the age of 40 suffers from degenerative and inflammatory diseases. Like in ladies, it is osteoporosis. weakening of the bone, osteoarthritis. Many patients are there which are suffering from the inflammation in the bone joints. This is called osteoarthritis. So in accidents also, many lost their bone, many bones have been damaged. So what we are doing, we are using the implants to join the bones. Implant should be compatible with the human body. Its surface should be such that it can enhance the tissue growth on the implant. The surface of the implant should be such that it will enhance the tissue growth on the surface so that the bone will join easily and abruptly in short span of time. This we are doing by using our powder mixed EDM. So sometime if today somebody got the fracture, they somebody have implanted some implants in or his or her body. After few years, there was problem. The problem started rising after few years. There may be redness on the joint. There may be some problem on the joint. There may be problem in the working of the joint. So ultimately, we are going to the doctor and doctor again recommending surgery, again resurgery. So it is not possible. Again, the patient has to go through the trauma, again the flow of the blood. So this, why we want this? No, nothing. This is not the solution. So we have modified the surface of the implant in such a way that the body will accept that implant easily, the bone growth start easily, and thus there is no need of the resurgeries. So we are trying to modify recently the artificial heart wall, the artificial vascular stents by using this technology, bone screws and bone plate by this technology, hip and knee implant by using this technology, knee implants. So amongst all these implants, replacement of spinal, hip and knee are extremely high. To meet the ever increasing demand of implant prosthesis, there is an urgent need for improved biomaterials. So many biomaterials are available in market. We are getting the coated implants, stent used in heart surgery. Is it possible that there will be no need of any coating? So in UIT, Punjab University, Chandigarh, we are developing the same surface properties on the metal surface itself, which otherwise we got after coating. So property requirement of the biomedical implant, type of the material should be low elastic modulus, should have low elastic modulus, yield stress, ductility, time dependent deformation, ultimate strength, material strength, high hardness, and appropriate surface topography are essential for interaction between bone and implant, which plays major role in osseointegration. So this is the pictorial view how nano surface will help for the growth of the tissue on the bone or bone implant. Among these techniques, EDM is one of the potential good candidate to modify the surface of the substrate at a nanoscale level. It can produce wear and corrosion resistant surfaces also, can produce nanoporous structure, pores with controllable size. The surface integrity modified by EDM process is more reliable than conventional techniques. So successfully by using the EDM process, by using the copper electrode, we are successfully able to generate nanoporous biocompatible recast layer on the surface of the implant. So our research team is further exploring the application of PM-EDM in the areas of medical science for manufacturing and surface modification of implants for orthopedic and other medical applications. The orthopedic doctors of PGI-MER Hospital, Chandigarh are also involved in this research work to clinically evaluate the biocompatibility of titanium implants in vivo and in vitro. One industrial house at Ludhiana, Punjab is ready to provide the raw material and other manufacturing facilities to explore this area. So we have got another 2 projects in this area, nano finishing of beta phase titanium implant from DST and UGC. We are working in this area, dear friends. Thank you very much. Thank you. So if anybody have queries, if anybody have question, most welcome.